Okay, the purpose of this video is to demonstrate how to rationalize a denominator. Now, what exactly does that mean? Rationalizing a denominator means that you want to somehow transform your expression so that there is no radical in your denominator. Okay, so somehow change this expression, make sure that it's equivalent, but have the radical sign disappear from the denominator. Now, it doesn't make any difference whether the radical sign is in the numerator or not. That's not the issue, but you just don't want to keep it in the denominator. That's just something that mathematicians have agreed upon, so that's what we try to do in this demonstration. Now, we're going to look at two types of rationalizing the denominator. The first type is where the radical in the denominator is a monomial. Okay? So if it's just one term, how do you rationalize? What are some of the strategies that you can use to rationalize that denominator? In another video, I'm going to demonstrate how to rationalize the denominator when it's a binomial, which is something a little bit different. Okay, so let's take a look at this particular example. Now, there's a couple things you can do here. Notice that I have 3 over the square root, which means that the index is a 2 in this particular expression here, okay? The 3 over the square root of 2. Now, what you can do, I'll call this my step 1. What you can do with this particular problem is to transform the radical sign into what we call fractional exponents. Now, what does that mean? You want to change the radical into 2 to some power that's some kind of a fraction. So the fraction is going to be the exponent itself. And this is what the answer here would be. It would be 2 to the 1 over 2. Now, how do you do that? There's a simple conversion that you need to know. And let's do it this way. This is the exponent, and this number here is called an index. Okay? In order to change a radical into a fractional exponent, you take the exponent and put it over the index. And then that would be your fraction that you would use depending on what you have here. So for example, if you had, I'm just putting this off to the side, let's say you had x, the cube root of x squared. To change that to a fractional exponent, you would say x to the exponent over the index. So you'd say the third root of x squared is x to the 2/3 power. Okay? So by that same token, let's go ahead and look at our particular problem again. Now notice that the exponent on the 2 is a 1. The index is 2, so you would say 3 over 2 to the 1 over 2, exponent over index. So once you've converted it to the fraction exponent, you want to ask yourself, how can I get rid of this particular fraction? What can I multiply this by in order to have this fraction disappear? Now, those of you who have taken my class before know that you would multiply it by some kind of a 1. Because remember, multiplying by 1 doesn't change the expression, it doesn't change the quantity of the expression, but it changes the look of the expression, or it transforms it into something more usable. Now, if you look at this for a little while longer, you'd realize that I could multiply this by 2 to the 1/2. Now, why would I do that? Well, you have to remember your laws of exponents. Now, what's the laws of exponents say? When your base, which is 2 here, is the same, and you're multiplying 2 bases, you add the exponents. So what is 1/2 plus 1/2? And it's 2 to the first, isn't it? because 1/2 plus 1/2 is 1. Now you have to multiply by 1 here, so I'm going to have to put the 2 to the 1/2 up here too. Now look what I've done here. I have multiplied by 1. 2 to the 1/2 over 2 to the 1/2. That's just multiplying by 1. It has taken care of my denominator because 2 to the 1st is just 2. So my radical sign has now disappeared. And the numerator, I've got 3 times radical 2, or 3 square root of 2. And what I do here is I just put this back under, I reverse this order, and I put the exponent over the index. The exponent over the index. And there's your final answer. Okay? I'm just going to do one more example for you on this particular problem on monomials. So we'll call this example 2. And let's just make it a little bit more challenging. Let's say I have the cube root of x squared over the third root of y. Okay, now what do I do with this? Well, again, I can change this to a fractional exponent. So what I'm going to do is I'm going to say x to the 2 over 3, exponent over index, divided by y to the, what's the exponent there? 1 over 3. Now, looking at this, and specifically looking at the denominator, what can I multiply this denominator by so that the exponent, or the radical sign in the exponent, disappears? Now, you may notice that a radical will appear if this fraction is not a whole number. So would you ask yourself, what can I add to that 1/3 to make the exponent a whole number? And the answer would be 2/3, wouldn't it? Top and bottom. Because that's multiplying by 1. And the laws of exponents say when the bases are the same, you add the exponents. So again, you're going to get y to the 1st. Now I have to take care of the numerator. Look what I have up here. According to this, both of these fractions are less than 1, which means that they're going to go back under the radical. If you notice that the denominators are both the same, and remember that the denominator is the index. The top part is the exponent. So it's going to be the cube root of x squared, y squared, and there's your answer. Okay, those are 2 examples. I hope that helped. Let me just go ahead and highlight that. I hope that helps for you. Go ahead and play this video a couple times if you want to remember the procedure and practice. Good luck to you.